Hello, my name is Paul, and this talk is called Build Your Next Website in Swift. For over 30 years, HTML has been a great language for describing the structure of our web pages. For example, we can write HTML like this. Here we have a heading, we have a paragraph of text, we have emphasis inside the text, and we also have a link to another page. But what happens if I forget this closing EM? Without it, browsers assume everything else that follows should also be emphasized, and that's not what I wanted. But it's easy to do because HTML is just text. But even if you were to write perfect HTML, there are other bigger problems. For example, we have browser compatibility. How can you make sure your pages look the same on all browsers that are out there? Or we have device compatibility. How can you make your page adapt to different screen sizes like iPhone and iPad? Then we have complex UI elements. How can you use more advanced things like drop-down menus or carousels or accordions? And most importantly, how can you be sure your site is accessible to everyone? Ultimately, all these boil down to one big problem. Most people don't have enough time to become experts in Swift and also experts in HTML. And so I want to suggest the solution is not to use HTML, or at least not directly. Instead, I want you to try building websites in Swift. Now, back in 2019, Apple announced Swift UI. There was the usual What's New in Swift presentation, and as part of that, they showed this HTML. And Apple also showed what it looked like in Swift. Except, of course, they just put the HTML into a Swift string. This code is objectively worse, because now we can't use HTML editors to get autocomplete or syntax highlighting. But then they showed this. This sample used what was then a new feature called a function builder, now called a result builder, to define the structure of our web pages in pure Swift and use that to generate HTML. So now the compiler can check our code is good, which means it's impossible to miss an ending tag by accident. Doing so will trigger an error straight away. And so I want to look at how we can build this for real. Rather than just having a DC demo, how can we use result builders to build a real HTML renderer? And we're going to start really small. In order to be valid HTML, a type must know how to render itself to a string. Because ultimately, everything we build has become a HTML string for output. So we can start with a protocol called HTML that says any conforming type must have a render method that returns a string. And now let's go back to Apple's Swift code from earlier, from 2019. We can choose a tag to build from here. Now, of all of them, this BR is easiest. It creates a HTML string BR/, a simple break in the lines. And so our code's easy too. We can send back the correct HTML for a new BR struct. Use it like this, and we're done. That's one HTML tag implemented. Next, let's look at this. Here, Apple's putting a string right inside the HTML. We can't just put this in its own struct, because it's a simple loose string. However, we can instead make Swift's own string type itself conform to our HTML protocol, giving it a render method that simply returns the string itself. We've got a string, send it on back. And now we can call render on a string like this. Now, obviously that's pretty pointless given we're just printing the string itself, but it's important soon. Back to Apple's code again. The next most complex is this title tag here. This becomes a HTML title element, so it has to accept a string to show in the page's title. So this time, we've got to have a property to store the text we want to use in our title. But we also need to have a custom initializer, because Swift's own synthesized initializer won't match the exact code shown in Apple's presentation. And now we've got a title tag working. Now, at this point, you're probably thinking two things. First, this is clearly very easy. And second, how does this use result builders? Well, it doesn't use result builders, but that's about to change because the next piece of code we're going to implement is this tag here, h2. This makes a second level heading in HTML, but as you can see, it works differently from the title tag we made earlier. This accepts a trailing closure of content to put inside the heading. So when the title tag only accepts plain text, you can put a range of things inside h2. You could have plain text, emphasis, links, and more. And this is where result builders come in. Inside, the closure being passed to our h2 could be any kind of HTML. So we need a way to convert several pieces of HTML into an array we can loop over. But we don't actually need result builders to make such an array. Instead, we can make a h2 struct like this one. This property stores a function that returns an array of HTML, which is exactly what we want. When it comes to rendering, we've got to call that content property as a function and it return the actual HTML to us. We can then loop over each item one by one and call its render method. And then finally send back the result. So now we have a new h2 struct that can work with any kind of HTML. And remember, this must be given a function that returns an array of HTML types, like you can see here. It's not pleasant, but it is powerful. Because we can put any collection of HTML inside there and it'll be rendered correctly. So a string, a line break, another string as one array collapsed down to one single h2. Now here, I want to take a brief diversion into what could have been, because result builders weren't the only major change introduced around Swift 5.1. For example, SEO 254 introduced static subscripts. Let's try one in our code. This means adding a static subscript to our h2 struct. It accepts 0 or more HTML objects and returns a string using our existing render code. So why would we want that? Well, with that one change, look how it takes the code from this all the way down to this. It's much nicer. But those commas are still there. Wouldn't it be nice if we get rid of them too? Well, SEO 257 tried to do exactly that. It proposed that line breaks could be used in place of commas. It even said directly, one case where visual clutter is especially pronounced is in domain-specific languages embedded within Swift, particularly when they are declarative. Now, what does that remind you of, right? This change would have allowed our code to be written without commas, leaving just that. And if that doesn't seem familiar yet, imagine if rather than using a h2, we instead used a vstack. We used those text strings as a text struct instead, and rather than writing br, we said divider. The result's almost identical to modern Swift UI without using any result builders. Sadly, this proposal met an extremely negative response on Swift Evolution and was rejected, so we can't use it. So this is where result builders are required today. First, let's go back to our closure approach, the code we had a few moments ago. We still want to remove those commas, and we want Swift to convert the contents of the closure into an array for us. To make this happen, we'll make a new struct called HTML Builder. Now notice this annotation. It'll be used as a result builder. So Swift automatically looks inside here for static methods that convert different kinds of content into output. There are lots of ways this can be called, but for now we'll use the simplest, static func build block. And this will be given a variadic parameter containing 0 or more pieces of HTML, and we'll send it back as a single array that can be looped over. Now internally, Swift converts these variadic parameters into an array for us, which means our output is just our input. And that's our result builder done, at least for now. Let's try it out. Right now, our h2 struct has a content property that stores the array of HTML it contains. To make it use our result builder, we're going to mark it with the HTML builder attribute, like this. And now when writing our code, our square brackets just go away. And those commas, they go away too. So using our h2 struct is much nicer. That one tiny result builder gives us incredibly clean syntax. And now it becomes trivial to go back to the original HTML Apple showed us and implement more of it. For example, this body type is almost identical to h2. Here's the complete code for the h2 struct we've just made. To make it a body tag instead, we change the struct's name from h2 to body. Then we change the HTML going back to body. Then it's done. That's it. We can use a similar approach to implement the A tag. But if you look at Apple's example HTML, you'll see it has a href method call. This is a modifier just like we have in SwiftUI, so we can implement it in a similar way. This uses our result builder just like h2 and body. But this time we also need a property to store the href attribute where the link sends users. To render the link, we render all its contents, then send back the appropriate HTML. Adding that href modifier means taking a copy of the current object, changing its href property, then sending it back. And now our HTML is much closer to Apple's. We have a page body, a heading, a line break, and a link. From here, we can carry on implementing the rest of Apple's sample. HTML and head are all that remains, both of which are just more of the same. But result builders can do so much more. For example, what if you want to have different HTML based on a condition, like this? This takes 3 small changes to our result builder. Here's the current code. First, we'll make it no longer work with individual HTML elements, and instead work only with arrays of HTML. We've got to flat map our result now so that 2-dimensional arrays become 1-dimensional. For our second change, we'll tell our builder that every time it sees a single expression that makes any kind of HTML, it will convert that to be an array of HTML. And that's enough to get our original behavior. Swift sees each individual part of HTML as an expression, then joins each expression into an array. But we want to add a condition in our builder. We want to generate some HTML only when showLink is true. But our builder wants to generate HTML. So what should it do when the condition is false, when there is no HTML to generate? Of course, in Swift, we represent the potential absence of data using optionals, and result builders do the same. So we can write a build optional method that will be given an optional array of HTML, and if the array exists, we'll send it back. But if it's missing, we'll send back an empty array. Of course, we don't want to render anything when there is nothing to render. And now our condition works. When the boolean is true, extra HTML will be generated. Let's go one further. What if we want one set of HTML when a condition is true and another when it's false? Here's the kind of code we want. It has an if block like before, but also an else. This is easy for result builders. We need to implement 2 methods, build either first and build either second. Both will be given an array of HTML from one side of a condition, and you decide what to do with it. Once again, we need nothing special here. We're given a HTML array, we're going to send back a HTML array, so our input is our output. And now we have if-else code working. In fact, it also enables switch case support because Swift compiles all the cases down to a binary tree of if-else checks. Now, all this so far is interesting, but not really useful. Yes, the compiler checks our code and that helps avoid mistakes. But think back to the 4 problems I mentioned earlier. Our result builder solves none of those. What we've seen is in fact pretty standard. There are several existing Swift projects that take code like this and build HTML in the same way, and they all suffer from these same problems. And like I said earlier on, all these problems boil down to one huge problem. Most Swift experts aren't also HTML experts. Right now, our code might use the same language as Swift UI, but it operates very differently. For example, when you make a tab view in Swift UI, it looks and works in varying ways depending on your platform. On iOS, you get a tab bar across the bottom. On macOS, we get control group with titles across the top. On tvOS, we get segmented control. On watchOS, we get a swipeable list of views with paging dots along the bottom. And then on visionOS, we get a floating ornament on the left-hand side. We haven't told SwiftUI how to adapt across devices or screen sizes, or how to handle user interaction. That's all done for us automatically. Because SwiftUI wants us to take a high-level, declarative approach. We specify what we want to achieve rather than all the individual steps required to get there. And so, when we want a scrolling list of rows, we write code like this, rather than have to specify all the internals of a list by hand and row dividers and scroll bars and whatever. And so what list becomes varies depending on the platform where our code runs. And SwiftUI automatically will switch for us between UIKit and AppKit and Core Animation and Metal, ensuring our code works great everywhere. We just don't care how complex the code is behind the scenes. All of that gets wrapped up behind a simple SwiftUI list view. Now, if you want the same here, if you want to let users have a huge amount of functionality without needing to know HTML, then we need our own external framework too. In this case, we're going to bring in a popular web framework called Bootstrap. Bootstrap provides for us a big chunk of CSS and JavaScript that's considered standard on modern websites, including what's called a reset style sheet, which is code that makes websites look the same on all web browsers. And so, before we even start doing any real work, just by including Bootstrap in our project, we solve the first of our 4 problems. No more browser compatibility issues. The second problem is making sure pages adapt to different screen sizes, and again, Bootstrap solves this. We can place content into rows of data, and tell it to render HTML inside there as columns of various sizes. And Bootstrap will then adapt its layout based on how much space is available. When the screen is wider, content's placed horizontally. But when we're in a portrait orientation, Bootstrap will automatically adapt. Our content's placed vertically rather than horizontally. And so we can build a row component like this. Just like our other components so far, it uses our HTML result builder, so it can work with any kind of HTML. This time, we're going to render the content using Bootstrap CSS classes, one for each column to be displayed for medium-sized displays, and another for the whole row. Using a new type looks just like our other HTML types. But now, we're generating responsive HTML. HTML adapts automatically to the device it's displaying on. And so, that's our second problem solved in just a matter of minutes. Bootstrap's doing a lot of work for us here. The third problem was trying to bring in more advanced UI elements like drop-down menus, carousels, and accordions. This again goes back to what SwiftUI does very well. We say, give me a list or a tab view or any other complex view. and it figures out how to make that happen, rather than us have to describe every step required to get there. Again, Bootstrap has lots of predefined controls built in, alerts, badges, navigation bars, and more. Let's look at just one briefly in a slightly simplified form, a drop-down button showing several options inside. This starts out similar to the A struct we made earlier. It needs a button title along with some items to show inside. As for rendering, this starts out by converting all the items into HTML list items. And then we'll send back a big string of HTML, because Bootstrap wants things in a very specific form. First, we make a wrapper element for the whole dropdown. Then we place the button itself inside there, using whatever title we're given. Finally, we make an unordered list to contain the items we want to show. Now you might think this is back to putting HTML into one big Swift string. But wait. What we've done here is encapsulate all the HTML inside our drop-down struct. So when it comes to using the component, we are writing, again, pure Swift. Just like how SwiftUI works, where we don't care what kind of UI kit code's behind the scenes. It's wrapped in neater, simpler code for us. Best of all, Bootstrap supports a standard called Accessible Rich Internet Applications, or just ARIA for short. So controls like this drop-down button work great with systems such as VoiceOver. And that's problems 3 and 4 solved. We've got lots of powerful UI components and we're building sites everyone can use. And that leaves us with one huge problem. How can we help Swift developers write great HTML? And right now, we're effectively encoding HTML in Swift. They still need to know what all these HTML tags do. But I've built this result builder following the code shown in Apple's presentation from 2019. But what if we rethought this completely and built something optimized for SwiftUI developers? What if, rather using structs like H2 and A, we can instead write code like this? Text with a foreground style and a font. Link with a button style, a divider, and more. That'd be great, wouldn't it? SwiftUI style code that can become HTML. I thought the same thing, so I built a new framework to do exactly that. It's called Ignite, and it builds on Bootstrap to provide an incredible website building experience for Swift developers. It supports all the HTML you need to build websites: text, titles, links, tables, lists, code, and more. It supports the extended range of Bootstrap controls like carousels, accordions, alerts, and more. It adds important metadata for search engines, social media, and accessibility. And it builds pages that work great on all device sizes. Most importantly, it lets you create entire static websites from Swift code, including using Markdown content for posts. It's built entirely in Swift with SwiftUI style result builders and modifiers. You don't need any HTML. Now, it's not trying to convert SwiftUI to HTML. That's a whole other project for someone else to do. Instead, it's a custom set of tools that help Swift developers build fast, beautiful, and accessible websites using the language they already know. Best of all, Ignite's available for everyone, open source, completely free of charge at github.com/2straws/ignite. Go and try it today. Hopefully, that's inspired you to build a website in Swift. Apparently, it's inspired my dog to build a site in Swift. Here they come. Let me know in the comments below if you would like to try out Ignite, want to try building in Swift, or even better, if you'd like to contribute, because it's an open source project. I'd love to have your pull requests. Until next time, folks, take care.